Okay, this is Introduction to Statistical Learning, Chapter 8, and we're on question 11 here. And so we're going to be dealing with the Caravan data set, and so we'll just kind of look at the questions as we go, but they're all right here if you want to look at it. Okay, so first we install and load the ISLR2 package that will contain the data that we need. And then we're going to get our data. And so first part here is to create a training set that consists of the first 1,000 observations of the entire data set. And then the rest will be our test set. Okay, so we call up the data. I'm calling it D here. And then I am converting the what will be our outcome variable into, it's currently in a factor, yes, no, and I'm turning it into an integer for 1, 0 to make some of the models that we'll use actually run here. Okay, so if a purchase occurs, then we call it 1. Okay, so now I'm going to divvy up my data set. So my first 1,000 observations are in the training index. So then I called the training data dtrain, which is just my data that has a row that is between 1 and 1,000. And then the test set is everything else. Okay, so minus training index. And then I further break this down into X variables, predictor variables, and outcome variable for test and train here. Okay, so the first thing that we'll do, I guess I should hide some of that stuff just so we get more stuff on the screen. So the first thing that we'll do is to fit a boosting model to the training set using purchase as the response variable, and we'll use 1,000 trees and a shrinkage value of 0.1. Okay, what values appear to be most important? So we need to install and load the GBM package, and then we just run this command, which really just looks like the linear model function that's native to R, assigning our shrinkage values, number of trees we want, etc. And then by running this summary function, it kind of gives us the importance, quote unquote, of the different variables across the different, I don't know what you want to call them, iterations or steps or whatever you want to call it of this boosting model. Okay, so here's the most important ones up here, and then as we go down we get less important ones, and it also gives us this nice little plot, but there's so many variables here that it's kind of hard to make sense of that. Okay, so that was part B. And now in part C, we're going to try to use the model that we just trained on the test data and see how well it does. And so we'll do that in a few ways. What is important here is that if the prediction says that a purchase will be made if the predicted probability is greater than 20%, we're going to say that they made a purchase. Okay, so it's a very low threshold, and we'll probably also account for some of the poor predictions that we're going to get here. And so we're going to look at it in terms of a confusion matrix, and then we'll also see the number of true positives. Okay, and then we'll compare this number to two other methods, KNN or K nearest neighbors, as well as logistic regression. Okay. So first, to predict, just the boosted model, so we just use predict. Okay, and then so this will give us a bunch of probabilities here, and then we need to declare that anything greater than 20% is a purchase. Okay, and so that's what this line right here is doing. And then we'll get a confusion matrix, which is just table, and then we say the thing that the actual values and the predicted values, and it will compare it for us. And then we'll use those values to find the true positive rate. So we run all that. Okay, and so here we have the predictions on top, the actual values on the the vertical axis here, and so we want to know the number of true positives. In other words, a purchase was predicted and actually occurred. So we look at the intersection of the ones, and we get 32 out of the rest. And okay, and so when you divide 32 by the rest, you get this number right here. I'm not saying that correctly. We want to divide 32 by the number of actual purchases that were made. Okay, so that's what we get. Wait, so sorry. Okay, we want to divide this number, which is when a purchase was predicted and when it actually happened, divided by the number of times we predicted a purchase, which is this number plus this number. Okay, that is correct. Okay, and so now we want to compare, this result to two other methods, and so we'll use k-nearest neighbors as well as logistic regression. Okay, so you can see the code here for making k-nearest neighbors. Right, we train on the x training data set, and then we test on the x test. Okay, and then what are we calling the classes? Well, it's the things that are in y train here. Okay, so it's going to be 1 or 0, or purchase or no purchase. And then we're, what's the size of our, neighborhood? It's 10. Okay, and so we could adjust that. 10 just seemed like a good, nice round number. Okay, and so then we need to access the predicted probabilities of being, in one or the other of these things. And so we need to look at, so the way it gets packaged from the K and N command is an attribute. So we need to get a hold of the attribute, and you can see how this works, and you can look at the structure of MK and see how this maps onto the structure of MK. It's not that terribly difficult. And then again, we're declaring that anything over 20%, the probability of 20% is a purchase. And then we'll look at the confusion matrix, and again we'll look at the true positive rates, and it's all down right here. Okay, and so there you have it. And so so it has a 13 or 14% true positive rate, which is worse than the boosted model. And now we can also look at the logistic regression. Okay, and I'll just let you look at the code here, but we do the same thing, declaring greater than 20% from the logistic regression output as a purchase, etc., etc. And then we look at the outcome, and once again we get a value around 14%. And again, that is considerably lower than the boosted model there. So, okay, we'll call that good.